So in this video, we are solving a question which came in 2021 paper 1 GCE. It was on question 12, and it says a piece of wood measures 25 centimeter long. Find the A upper and lower limit, B the percentage error. So in finding the upper limit, first we need to have the absolute error. So we say absolute error. So absolute error, or just say AE is equal to, so since here we have a 25, which is a single number, it will be represented by a 1. Just a 1, since it is a whole number, divide by a 2. So what we are doing is 1 divided by a 2, which we are getting in decimal places as a 0.5, like that. So that will be our absolute error. But if we are given, let's say we were given a something like 25.1, if it has a decimal point, when finding absolute error, you can say absolute error is equal to, so this 25, it will be represented as a 0. So the 25 here will be represented as a 0, and then this one here we take it as a 1. So I'm going to write a 0 and then point a 1, and then we divide by a 2. So when we divide a 0.1 divided by a 2, we are getting a 0.05. So that will be our absolute error if we add a 25.1. Another example. So if we add a 25 with two decimal places, let me say 0 and then you have a 2, like that. So in finding the absolute error, we will say absolute error, let me just write that one well. So we will say absolute error is equal to, so this 25 will be a 0, and that 0 also will be a 0, and now the last number here, the last digit, it will be a 1. So it will be 0.01, and then we divide by a 2. So when we divide 0.01 divided by a 2, we are getting a 0.005. That will be our absolute error. So that's how to find the absolute error. So we continue to our question. So we have found our absolute error to be 0.5. So the upper limit, finding the upper limit. So this one is our N. So let me say upper limit. So in finding the upper limit, we'll be getting a 25, which we are given, which is a measurement for the hood. So we say a 25, you say plus, you add the absolute error. So adding a 0.5. So what are we getting when you add the 25 plus a 0.5? So our answer will be 25.5. That will be our upper limit. So whenever you're finding an upper limit, you add the absolute error, and then if it was a lower limit, we will be subtracting our absolute error. So now finding for the lower limit, you say lower limit is equal to our measurement, it is 25. Now this time we are subtracting the absolute error, so we subtract a 0.5. So when we subtract 25 minus 0.5, we are getting say is equal to 24.5. So that will be our lower limit. So for question 1 we are done. We can now go to question B. So question B, I will write it this side. So question B, they want us to find the percentage error. Percentage error, you can't really find percentage error direct, but first you need to find the relative error. So relative error, I can say relative relative error is equal to absolute error is equal to absolute error is equal to absolute error over true, can say true value or true measurement. It is true. Okay. So in short, percentage error is simply the percentage of the relative error. So when you find the relative error, you multiply it by 100. You are getting the percentage error. So relative error, you can say relative error is equal to absolute error. We found a 0.5. So we say a 0.5 and then over the true value we have a 25. So we divide a 0.5 divide by 25. Maybe you can multiply by 100 to work with the whole numbers. You can say, let me multiply by a 10 since I have one decimal place here, so that you work with the whole numbers. So let me just say I multiply by a 10, let me say by a 10 on both sides, then down multiply by a 10 like that. So we are multiplying the 0.5 times a 10, we are getting a 5 over 25 times a 10, we are getting a 250. So now we can divide 5 into 5, it is a 1. 5 into 25, so here a 1 into 25, we're getting a 5. So our relative error is equal to 1 over 50. That's our relative error. So now finding percentage error, you can say percentage error is equal to the percentage of the absolute error, and then our percentage of relative error, which we found to be a 1 over 50. Percentage you multiply by 100%. So you can just simplify. You divide here and there you divide. So it will be 1 times a 10. We are getting a 10, and then a 10 divided by 5. We are getting a 2%. So 2% was our percentage error. So that's it for this video.